Let's look at two aspects of factoring polynomials in this lesson. The first thing we're going to do is we are going to look at how to factor out the greatest common factor, and then we'll look at how to factor trinomials. We'll actually look at two different trinomials setups when we get to that step. When we factor polynomials, what we're trying to do is we're trying to rewrite it as a product of things. Factor means it divides evenly into a number, or it is part of the numbers that multiply to give you a term. For example, 6 is equal to 2 times 3. That would be a factorization of 6. It's also equal to 1 times 6. That would be a factorization of 6. Now, this factorization isn't very useful, but this sometimes could be. So factoring just means to write it as a product of things. When we do this, we're going to encounter one thing always we want to look for, and that is trying to find a greatest common factor, something that can be taken out of every single term. And then we're going to see we'll have two terms left over in some cases, or three terms left over. We're going to be looking at these three-term ones for the most part today, but don't be surprised if you see a two-term polynomial. Just the GCF, greatest common factor. So here's my polynomial, and we've got three terms, 1, 2, and 3. I've just said it's equal to this because I'm just going to work on this right-hand side, so you always have this original to look back on. Greatest common factor means try to find something that divides into all three of the terms, or four terms, however many there are, evenly. So you want to look at your coefficients first. The coefficient, if it isn't given, it's always just a 1. Well, 1 is only divisible by 1. So that's the biggest number that anybody gets to be divided by, 1. And dividing by 1 doesn't really help you out. Let's look at the variables next. X cubed and x squared and an x. Now these are factors. Remember, this is x times x times x. This is x times x, and this is just x. So that's x is a factor 3 times, x is a factor twice, and x as a factor 1 time. So the most number of x's they have in common is just that single x. So we are going to rewrite it as x, and I'm taking that x out of each term and reducing it therefore by 1x. And there I've taken out the GCF. So the GCF is this. So if we can find a color you can see is the x. And now I have that factored. It's not factored. Maybe I could factor it further, but that's all we're doing right now is the GCF. Check your coefficients and then check the variables. So 5, 10, and 20, they're all divisible by 5. So I'm certainly going to factor out a 5. And then I'm going to look at the x's. X's here. X to the fourth, x cubed, x squared. So the most they have in common is an x squared. So that's my GCF. Now, when you're trying to figure out what goes inside the parentheses, what you basically are doing is dividing each of these by 5x squared. Like so. And so you're just simplifying these fractions. 5 over 5 is 1. X to the fourth over x squared. Just subtract your exponents. What's happening is you cancel two of the x's in the numerator with the x times x in the denominator. The next one, we go negative, and it's 10 divided by 5, so it's 2. And x cubed over x squared, two of them cancel, leaving you x. And then lastly, 20 divided by 5 is positive 4. X squared over x squared is just 1. And so you've taken out the GCF, and your GCF would be this 5x squared there. And there we have it factored. The second type of factoring we're going to do today is factoring trinomials like we just did, but instead of taking out the GCF, which we are going to always look for, we're going to focus on just trying to unmultiply this, trying to take this ax squared plus bx plus c and factoring it as two binomials. This is x plus r and x plus s. Okay. Now the trinomials we're going to do today, the x value is just going to be equal to 1, so you won't see an a there. The a will just be implied to be 1. You can see it down here in the example. This is a 1x squared plus bx plus c, And what we want to do is factor it as an x plus r, one binomial times another binomial x plus s. Now to do this, to figure out what r and s are, we know the x and the x. To figure out r and s, we want r times x, s, to give us the value of c. Well, what's c? C is the constant term. But at the same time, we want r plus s to add up to b. So let's first identify our a, b, and c. So a is 1 right there. B is 4. And C, let's get the color we can see. Oops, green will work. And C is the 3. And so to factor this trinomial because it has 3 terms, what we want to do is just go C equals 3, and we make a list. R times S has to be equal to C. Well, here's my R times S has to equal C, so R could be 1 times 3 because C is 3. Okay, that's the only combination that gives you 3 when you multiplies to give you 3. Let's check the other condition. The other condition is if you add R with S, you better get equal to B. Well, B is 4 for us, so yeah, if we add those, it does equal to 4. So they multiply to 3, they add up to 4, and so we know this factorization must be x plus R, 1, and x plus S, 3. And so the complete factorization, and usually you wouldn't write this x plus r right up here. We would just say x squared plus 4x plus 3 equals x plus 1, x plus 3. Oops, and I erased by accident. Let's just check this really quick so you can see that it actually works. X times x is x squared, so I'm just redistributing. And then x times 3 is 3x. And then 1 times x is 1x, and 1 times 3 is 3. You can see we get these like terms in the middle. X squared equals 4x plus 3. So it does equal what we started with. So let's look at a few catch on to it relatively quickly. So as soon as I see this trinomial, you want to check your a. Well, first make sure it's in standard form, x squared, then x to the first, then constant. Check your a value. Your a value is just 1, and so you know you can use this method. Make your 2 sets of parentheses. You know it's got to be an x times x because that's what gives you x squared. Then just run off to the side. Here's our a, b, and c value. A is 1, b is 7, c is 10. Keep in mind that C10 because C is 10. R times S has to give you 10. So let's make our possibilities. To get 10, it could be 1 times 10. That multiplies to give you 10, or it could be 2 times 5. That multiplies to give you 10. It could also be negative 1 times 10, and negative 1 times, or negative 1 times negative 10, and negative 2 times negative 5. Now I'll tell you why I'll show you here as we discuss it why you don't really have to list these negatives. What you want to keep in mind is the product has to be 10, but they have to add up to a positive 7. Well, you aren't going to write down the negatives because there's no way two numbers can be added that are both positive that add up to a positive number. So in this case, if we add these together, they add up to 11. So that doesn't work. Remember, they have to sum to the b value. We add these up, they equal the positive 7. There's no way these negatives would ever add up to a positive 7. Okay, so we know it has to be the 2 and the 5 because they multiply to 10, they add to 7, so we go plus 2 and plus 5. Just r plus s, or r and s. We can check it really quick. Notice our first terms, they give us the x squared. This product here gives us 5x. This product here gives us 2x. And then this final gives us 10. You can see those middle terms. That's where that 7x comes from. That indeed does equal the original problem. So this is the correct factorization. You don't have to show that so you understand where it comes from. Here we go. Let's factor this guy. I notice right away A is 1. Good. B is negative 5 and C is negative 6. So I write my two parentheses, x and x. Let's figure out what R and S are now. So they have to multiply R times S to give me this time a negative 6. Let's see here, it could be 1 times negative 6, or it could be negative 1 times positive 6. It could be 2 times negative 3, or negative 3, negative 2 times 3. It's going to be one of those possibilities. Now they have to add up to negative 5. So let's see what these add up to. If we add them, they add up to negative 5. I'm done. See what these would have added up to. They add up to positive 5. These add up to negative 1. And these add up to positive 1. The only one it could be is this guy right here. So it's plus 1 minus 6. We could double check it, but you can see the x times the x gives you the x squared. These last ones always multiply to give you this last term, which they do. And then we just check this product. It's negative 6x's plus 1x's add up to negative 5. And we're done. Get pretty quick at these things. A is 1, B is 1, C is negative 12. So R times S has to equal negative 12. So it could be a 1 times 12, a 2 times 6, or a 3 times 4. Now I'm not going to keep track of this sign right now. I know that one of them's got to be negative. Okay, so this time I'm not listing all these positive negative combinations. We're just going to think through it. Okay, so I know they have to be a negative. One of these is going to be negative. And what does it have to equal when they add up? They have to equal 1. So if I want these two to equal 1 when I add them together, there is no way. I could make the 1 negative, but they add up to 11. I make the 12 negative, but they add up to negative 11. So it's going to be one of those. That doesn't work. Let's try the 2 and the 6. When I add them up, let's see what I get. One of them's got to be negative. If the 2 is negative, they'd add up to 4. If the 6 is negative, they add up to negative 4. Well, that doesn't cut it. Let's try the 3 and the 1, or 3 and the 4. See here, if the 3 is negative, they add up to 1. That's what I want. So I'm going to make my 3 negative, my 4 positive, and then they add up to the b value of 1, and I'm done. X is negative 3, x minus 3 rather, and x plus 4. Mentally, let's check it. The first x times x gives us x squared. The last one's negative 3 times 4 gives us negative 12. This first pair in them are right, oops, not that pair, this pair, the ones on the outside. X times 4 is 4x. These inside, negative 3 times x, negative 3x. So 4 minus 3, 1x in the middle. Let's see here, we got a couple left. So I look at it real quick and I go, A is 1, and then I pause for a moment. Because notice this, it's an x cubed. We haven't done any x cubed problems. Oh yeah, we better check for a GCF. So I check it. 1 is the coefficient, 4 and 5. So I could only take a 1 out. That doesn't help. But everybody has an x in it. So let's go ahead and take that x out first. X squared minus 4x minus 5. There we go. Now what we're going to do is we're going to try to factor that trinomial x and x. I just got to figure out what R and S is. So my A value is 1, my B is negative 4, that's what they add to, and my C is negative 5, that's what they multiply to. So R times S has to equal to negative 5, but R plus S has to equal negative 4. Always start with the multiplication to limit what your answers could be. To get a 5, we've got one choice. It's got to be 1 times 5. To get them to add up, plus equals, to get them to add up, they have to equal negative 4. It better be a negative 5. Let's see here. 1 times negative 5 is negative 5. 1 plus negative 5 is negative 4. And therefore we know it's going to be a plus 1 and a minus 5. And we're done. Notice we include that GCF in our final answer. Next one, here we go. Ooh, only 2 terms. Let's check for a GCF. 3 and 48, yeah, they're both divisible by 3, and I can take out at least a y cubed. So we're going to pull out a 3y cubed. Now remember, you just set it up kind of like a division problem. 3y cubed, 3y cubed. 3 over 3 cancels, y to the 5th over y cubed. 3 of them cancel. 3 and 48. 3 goes into 48 16 times. And the y cubes cancel. Now let's check this guy. Y squared minus 16. It's kind of a freaky one. It doesn't have a middle term, but it is quadratic. It is y squared. Let's see if we can factor him. So we run off to the side, and I'm just going to try to factor y squared plus 0y plus 16 minus 16. Notice I put in that 0 to make him look like a trinomial that I'm used to factoring. A is 1, B is 0, because there isn't one, and C is negative 16. So I want to find 2 numbers who multiply to C. Let's list them. Could be 1 times 16, could be 2 times 8, could be 4 times 4. Now they have to add up to the B value, so they have to add up to 0. Well, this doesn't add up. It'll never equal 0. These 2 numbers are never going to add up to 0. But these 2, the 4 and the negative 4, they do add up to 0 if one of them is negative. And so I'm going to use that for my factorization. It is y plus r is negative 4, and y plus s, and that is positive 4. And there is my complete factorization. You can check this little product here. First terms, y times y, give us y squared. The last terms give us negative 16. But this outside pair, 4y, inside pair, negative 4y, they cancel each other out. There we go. Let's put this thing all together here real quick. Let's check for a GCF first. 5, yep, everybody's divisible by 5, and they all have a z squared in them. So we go 5z squared. Let's take it out of each of these. So we have a lot of canceling going on here. 5 over 5, that'll be z squared, so that's z squared. The next one's 30 divided by 5 is 6, and z to the first. So we just go z, and 5 into 45 9 times, and the z squareds cancel each other out. We have a trinomial, so we're going to factor this trinomial. We know it's going to be z and z, and we go, all right, r times s. You've got to equal the c value, 9, but then you're going to have to add up to the b value. So when they add up, they got to add up to 6, this b value. So it could be a 1 times 9. It's not going to add up to 6. Could be a 3 times 3. That will add up to 6 as long as they're both positive. And that multiplies the 9, so z plus 3 and z plus 3. And we're done. Okay, so that's what your assignment looks like today. Just factor these trinomials. R times s has to give you c, and r, there we go, has to equal c, and then r plus s has to equal that b term, or that b coefficient.